Process hollowing theory. There are a few steps we must perform and components to consider, but the most important is the use of the create suspended flag during process creation. This flag allows us to create a new suspended or halted process. When a process is created through the Create Process API, the operating system does three things. First, it creates the virtual memory space for the new process. Next, it allocates the stack along with the thread environment block and the process environment block. Finally, it loads the required DLLs and the exe into memory. Once all of these tasks have been completed, the operating system will create a thread to execute the code, which will start at the entry point of the executable. If we supply the create suspended flag when calling create process, the execution of the thread is halted just before it runs the exe's first instruction. At this point, we would locate the entry point of the executable and overwrite its in-memory content with our staged shellcode and let it continue to execute. Locating the entry point is a bit tricky due to ASLR, but once the new suspended process is created, we can turn to the Win32 ZW Query Information Process API to retrieve certain information about the target process, including its PEB address. From the PEB, we can obtain the base address of the process, which we can use to parse the PE headers and locate the entry point. Specifically, when calling ZW Query Information Process, we must supply an enum from the Process Information class. If we choose this class, we can obtain the address of the PEB in the suspended process. We can find the base address of the executable at offset hex 10 bytes into the PEB. Next, we need to read the PEB address. While ZW Query Information Process yields the address of the PEB, we must read from it, which we cannot do directly because it's in a remote process. To read from the remote process, we'll use read process memory, which is a counterpart to write process memory. This allows us to read out the contents of the remote PEB at offset hex 10. From here, it gets a bit complicated, and we need to do a little math, but we begin with the base address that we already found. Then we'll once again use read process memory to read the first hex 200 bytes of memory. This will allow us to analyze the remote process PE header. The relevant items are shown in the PE file format header. All PE files must follow this format, which enables us to predict where to read from. First, we read the ELFA new field at offset hex 3C, which contains the offset from the beginning of the PE image base to the PE header. This offset is given as hex 80 bytes, but can vary from file to file. The PE signature found in the PE file format header identifies the beginning of the PE header. Once we've obtained the offset to the PE header, we can read the entry point relative virtual address, RVA, located at offset hex 28 from the PE header. As the name suggests, the RVA is just an offset and needs to be added to the remote process base address to obtain the absolute virtual memory address of the entry point. Finally, we have the desired start address for our shellcode. The details of this attack may seem daunting, but it provides us a way to hide in any process we can create, masking our presence.